Okay, in the last lesson we learned how to write formulas when I gave you the name of an ionic compound. This time we want to go backwards, and I'm going to give you a formula and I want you to turn it into a name. This is a little harder for a couple of reasons, but mainly this is harder because some cations are going to need a Roman numeral. And let's review that before we begin. Any cation that can have multiple charges, such as iron can be +2 or iron can be +3, and there are others like lead can be +2 or +4. You have to recognize ions that can have multiple charges. And to make sure you're communicating which charge is being used or found in a particular formula, you need to use the Roman numeral. So to say iron 2 is being used to make this ionic compound, we'll put the 2 in the parentheses, the Roman numeral 2. To review briefly what elements form multiple ions, you need to be wary of any transition metal. So that's the entire D block, even though that is not exclusive. We're just going to say if it's in the D block, you need to suspect that there's going to need a Roman numeral. And then the lower P metals. Those are the heavy P metals, such as lead, tin, thallium, things like the very bottom left of the P block. Before we begin, make sure you do have your periodic table out and your polyatomic ion chart out, so you can use those as references. At any time, hit pause and try to find the ions that I'm referring to, or for the elements that I say need a Roman numeral, find them on the periodic table. Get good at this. Don't struggle with this Roman numeral thing because you don't know where certain elements are on the periodic table. Okay, let's begin. In problem number 1, we have NaF. The first thing you need to do is decide where the cation stops and where the anion begins. Most of the time, the cation is only going to include one capital letter. Other than ammonium, a polyatomic ion, our cations are all going to be monatomic metals from the periodic table. So what I did when I was learning to do this is I would draw a line between the cation and the anion based on when I saw the next capital letter, knowing that cations can usually only have one. So here I've separated this formula into a cation. Now I just name it. For sodium, sodium is in the first group. It's an alkali metal, so I don't have to worry about Roman numerals. So and I know I can just name those sodium. Sodium ion or sodium cation is more correct, but I don't need that for the overall name. And then the anion is F. That's monatomic, so it comes from the periodic table. That's going to be fluor, and monatomic ions all end in "ide." Every one of them. All right, I kind of got this out of order. I'll fix it on the next one. So that's what I should have put in the first place. That's okay. Now, so do we need a Roman numeral? The answer is no. Sodium is an alkali metal. You never need Roman numerals for alkali metals. So the name of this compound is going to be very simply sodium and fluoride. You just bring down the names of each anion. Easy peasy. In number 2, let's take a closer look. This one looks harder because there's lots of capital letters going on. It may not be totally obvious where the cation stops and the anion begins. But as I look, I see a capital letter here. So that tells me the cation has strontium, capital lower. And then now the second capital letter shows up here. This isn't ammonium, so I know then that my cation is just going to be Sr. Strontium is an alkaline earth metal. It's always +2. That leaves the anion as this CrO4. Again, there's only 2 parts to an ionic compound, so the anion had to be all this stuff. That makes it polyatomic. So go to your polyatomic ion chart. Use your finger, scroll down till you find it. You'll see that this is called chromate. and it has a -2 charge. That's why we don't see any subscripts. +2 had to cancel with -2. So we have chromate, and the cation is just strontium. Do you need a Roman numeral? Again, no. Strontium is an alkaline earth metal, and they are always +2. The complete name of this ionic compound then is strontium chromate. Number 3, this time the cation is going to be Fe. You can see a little dividing line there, the second capital letter. And the anion is going to be O. Now, oxygen is pretty easy. The anion is always in charge in an ionic compound because it's more electronegative than the cation, always. It gets to fulfill its octet. So oxygen, we know then, is -2. And that is going to be called oxide. Monatomics, again, always in an ide. Now, what makes this hard is that iron can be multiple ions. So we will need a Roman numeral here. Figuring out what that Roman numeral will be is going to require you to use oxidation number algebra. So we need to come back and think about this. We know that the oxygen is -2, but what is the iron? Using some algebra, there are 2 irons, so there's 2 times the X, or unknown charge, plus there are 3 oxygens that are each -2, and those 2 have to add up to equal 0. So 2x minus 6 equals 0, 2x equals 6, and in this case x equals +3. So this cation is +3, and we need to call that iron 3. The full name of this compound will be iron 3 oxide. Again, please learn that Roman numerals are not subscripts. They are charges. Unfortunately, it's just not that easy. Looking at number 4, we need to find and separate that cation from all this. One capital letter, here's the second. So most of you would immediately want to divide between the N and the H. But no, this is the one exception to that. This is ammonium. It is a polyatomic. It's the only positive polyatomic ion you have to deal with. And that ion is NH4 positive, 1 charge. So that leaves the OH as the anion. From your list, you should see that that's negative, and that is hydroxide. Do you need a Roman numeral? No. There's no metal in here whatsoever. So the name of this compound is going to be ammonium and then hydroxide. Let's do this one more, and then we can get more practice done in class. The cation here is going to be the Pb, and then go find Pb on the periodic table. Is it in an area where you have to have Roman numerals? And the answer is yes. It's not transition, it's a P metal, but it still, because of its size, can have multiple charges. The anion here is NO3. NO3 is recognizable as nitrate, so from your list of ions, you can write that as -1 charge. And we can go ahead and put the name down for that one, nitrate. So we need to focus on lead and see what charge it's going to be. Using our algebra, like we did on the iron problem above, I know that the nitrate is -1, and we're unsure of the lead. So this time we have X, and there's just one lead, plus we have 2 nitrate ions that are each -1, and they have to add up to 0. X minus 2 equals 0, so in this case X equals +2. So the lead in this problem is +2. That makes it lead Roman numeral 2. The name of this compound would be lead 2 nitrate. All right, if you have any questions on that, ask, and let's get our practice done in class. And let's make this a mastered subject. This is something students struggled with last year. Let's not do that this year.